Good morning. This is the third lecture of the integrated circuits and applications. So in previous lecture we had discussion of differential amplifier advantages, how single stage CE configuration is converted into the differential amplifier. Also we discussed in the last lecture how single stage amplifier is designed based on the given specifications, that we also going to perform in the laboratory as a very first lab exercise, practice exercise. Then we match the simulation result with the specification value, theoretical calculations. In this lecture we start with the typical differential amplifier. So we are going to check all four possible types of differential amplifier. What are the advantages of differential amplifier? As I said that it has a two input terminals and two output terminals. So noise, in terms of noise, this differential amplifier is much better as compared to single stage C configuration. So that we are going to check for the differential amplifier. At the same time, we have a two major analysis for all four possible types. There are four possible category of differential amplifier. If it has a two inputs, two output, it is called dual input balance output differential amplifier. If that is a first category. If it is a second category, two inputs and one output, it is called dual input single ended output. Third category is single input dual output, and fourth category is single input and single output. So in this way we have four possible types of differential amplifier. This differential amplifier is very first stage of op-amp. So in detail we are going to check the voltage transfer characteristics of this differential amplifier, how DC analysis we are going to perform by using the H parameters or RE parameters. So for DC analysis, operating point is very important. So we are going to calculate ICA and VCE value. And second analysis is AC analysis, where we are going to check open loop gain, that is a DC gain, input impedance, output impedance, CMRR, differential gain, and common mode gain. So these are all AC parameters by performing the AC analysis. So overall in this lecture number 3 we pick up the differential amplifier, and we start with the very first type, that is a dual input balance output differential amplifier. It has two input and two outputs, and step by step we first check the DC operating point of this differential amplifier. By applying Kirchhoff voltage law and Kirchhoff current law, we are going to check the operating point of differential amplifier as a first configurations. So IC and VC, and then we are going to sketch the VTC curve also, voltage transfer characteristics, input voltage versus output voltage. So for given dual input balance output differential amplifier, which is the first stage of op-amp, internal to the op-amp, we are going to plot this VTC curve based on the DC analysis, and then we take few example also, practical values also, and you have to calculate the IC/VC value for given value of beta, HFE, like that. Second analysis, AC analysis, that we are going to perform in the detail. So as I said, what is the DC gain of this differential amplifier? What is the input impedance of this differential amplifier? What is the output impedance of this dual input balance output differential amplifier? And output impedance, then CMRR, common mode rejection ratio. How we can modify the common mode rejection ratio for this dual input balance output differential amplifiers. So once you understand this all parameters for first configurations, it is easy to convert for the remaining three. So for remaining three, I am not going to derive same value, just you have to apply some trick in such a way that you can convert, you will get all these parameters value from the first configuration, that is dual input balance output differential amplifier. So let's start with this title, differential amplifier, with specifically first configurations. Thank you.